Okay, so we're now going to look at example 6. This is piggybacking off of the example we just did. So we want to approximate this integral, but we've already done this integral without the limits of integration. So what we get when we take that integral, it's just going to be exactly what we got before, sum to infinity n equals 0, negative 1 to the n, x to the 5n plus 6, divided by n plus 1 times 5n plus 6, evaluated at 0 and 0.5. And when I plug in the 0.5, I'm going to get 0.5 to the 5n plus 6. I get a 5n plus 6 there on the bottom. Minus, and when I plug in 0 for x here, it's going to zero out everything in that expression because I'll get a 0 in the numerator. So I can basically just ignore that. This is the thing I'm trying to calculate to the nearest 10 to the negative 6. And notice that it's got a negative 1 to the n, so it's alternating. So I can use my alternating series estimation here. So I really just need the first term of this particular series that's less than 10 to the negative 6. So that's 0.000001. So let's just try plugging in n equals 0 and see what I get. When I plug in n equals 0, I'm getting negative 1 to the 0, so that's just 1. I'm getting 1/2, that's my 0.5 to the 6th power, divided by 1 times 6. Plug that into your handy-dandy calculator and you get 0.0026 something. So that is not less than the thing that I need. Let's try n equals 1, and we would also call this a0, that's my first term. A sub 1 is my second term. And when I do that, I get 1/2 to the 11th divided by 22. Is that right? Yeah, because it's 2 times 11. And when I plug that in, I get 0.00002219. This is still greater than the thing that I need, but it's decreasing rapidly. So I go ahead and do the same thing for my a sub 2, and when I do that and plug those in, I actually get something with 6 zeros and then a 3, 2, which is in fact less than 0.000001. And this means I only need to add up to the a sub 2 term, which means I'm just doing a0. When I plug in a1, I was looking at the positive part, but if I plug in n equals 1 here, my negative 1 to the n would give me a negative. So I'm actually going to get this a0 minus the a1. So that's like 0.0026 something minus my other 0.000022. When you do that calculation, you end up getting 0.00258,198. And if you actually do this in Maple, so you can actually plug in 0 to 0.5 natural log of 1 plus x to the 5th dx. Sometimes Maple wants to do it symbolically, like it wants to actually calculate the integral and then plug things in. Numerical integration, there's a way to do, like, if you type in evalf and then you do like int parentheses and you plug in the function. I can't remember what exactly the form of it is. And here you would do x equals 0 dot 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 0.5. It'll do a numerical integral. And I believe, at least when I did it last time, I'm not doing it right now, I got 0.0025828. This thing that I just wrote here, that's the actual value, and this thing up above is what we approximated it to. So you can see that we actually did approximate it fairly closely just by adding up the first couple terms, which is pretty impressive if you think about it. All right, our very last question here. Finding sums of series using power series representations. So suppose I gave you this particular series ages ago. You would have done the ratio test on this thing or the alternating series test, and you would have been able to say, oh yeah, this thing converges. But then if I said, what does it converge to? You wouldn't have any idea because it's not geometric and it's not telescoping. I can rewrite this if I wanted to make it a little bit prettier as negative 1/5 to the n times n. The negative 1/5, that looks geometric, but because you're multiplying it by n, that throws everything off. So what do we know? Well, we know if I do the sum to infinity of n equals 0 of x to the n, that's equal to 1/1 minus x. What I want to do is I want to do some manipulations to this left-hand equation over here, to that series, by doing derivatives and integrals to make it look like, whoa, this thing over here. And when I do that, what I'll have on the other side over here, after I've done some derivatives and integrals possibly, is I'll have a function. And then I can just plug in a certain value for x and get my result. So how does this work? Well, let's see. I notice that I have this n here, which means I'm going to need to have an n somewhere in my expression here. But if I take the derivative of this thing, of my x to the n, well, that's the same thing as getting the derivative of 1/1 minus x. Of course, only in situations where the absolute value of x is less than 1. And if I take the derivative of x to the n, that's just going to give me nx to the n minus 1. I've still got a series here. One thing to note is that I wrote n equals 0 here, but we actually can't do n equals 0 because that would give us an x to the negative 1. So we start now at n equals 1. One way to think about that is that when you take that derivative, it eliminates the very first term because that would be your constant term. And if I take the derivative of 1/1 minus x, I'm going to end up getting a, it'll be a 1/1 minus, so this is like 1 minus x to the negative 1. So I'll get a negative 1 minus x to the negative 2, but when I take the chain rule and take the derivative of the inside, the negative will cancel out. So I end up getting a 1/1 minus x squared. And here's the cool thing. Suppose I let x equal, negative 1/5. Then this thing here becomes a n negative 1/5 to the n minus 1. And this thing over here becomes a 1/1 minus negative 1/5 quantity squared. Now, this is not exactly what I want. I want to have it be a negative 1/5 to the n power. But I'm pretty close. So let me finish calculating this. This is 1/6/5 squared. That's 1/36/25. Multiply by the reciprocal, and I get 25/36. So how do I convert this thing that I have to what I really want? I'll do that in black. Well, what I want is n times negative 1/5 to the n. And all that means is I have to take the thing that I have in blue up here, and I need to multiply it by a negative 1/5. Because if I have negative 1/5 times the n minus 1 and I multiply that by a negative 1/5, that's going to give me negative 1/5 to the n. So this is going to give me, what I'm saying is that expression with the n is just negative 1/5 times what I had before to the n minus 1. But I already figured out that that whole thing is equal to 25 over 36. So this is a negative 1/5 times that.
Hi, how are you?
Equals negative 1, sorry, negative 5 over 36. And my wife's doing something in the back.